Yeah, 2 minutes.
Yes, yes.
Okay, we'll start. Hi guys, good morning. So, as part of today's workshop, we'll be discussing about introduction to machine learning and the statistics part, which are required for data analysis. So, first we'll start with machine learning. Quickly share my screen. Yeah. So, first of all, let us understand what is machine learning. Then we'll be discussing about how it is differ from traditional programming, why machine learning is important, what are the major problems the machine learning can be solved, what are the different types of machine learning, and also the basic terminologies we will be discussing. And then we'll be discussing about the architecture part, then the tools which are required to build model, fine tune the model. Then we'll slowly move into the statistics part, and also we discuss the different types of statistics and measures of central tendency and measures of dispersion. Yeah, so machine learning. So many authors and so many research scientists have given different explanations for machine learning. This Arthur Samuel described it as the field of study that gives computers the ability to learn from data without being explicitly programmed. So basically, we'll just split this word machine and learning. So first of all, uh, learning is the thing is a continuous process. We are making the machine to learn. So as we already discussed in yesterday's workshop, the machine does not have any intelligence. Only the human have the intelligence. But the human lack in storage and processing a huge amount of data, where the machine has the capability to store a huge amount of data and process in a very quick manner. So in order to do in order to fine tune or in order to learn a good amount of data, we reach out to the machine. So basically we are feeding the machine the data. So machine learning is all about the data. Without data we cannot do anything, right? So for example, uh, um, a good example like diagnosis, for example, if it's a cancer diagnosis or whatever it is, uh, diabetes diagnosis, we have to tell our problems to a doctor or whatever it is. So first of all, they need to understand the history. What is the condition you are in? What are the symptoms you are in? So until unless you tell the symptoms to a doctor, he cannot suggest you the corresponding tablets or so and so. So the data is very much important. So we have to be very specific in providing the information to a doctor, and the doctor in terms he will ask you in his own way, because he has already analyzed different patients. You are one among them. You are one among the training data for him. He has already seen so many data during his period of service or during his internship or something. So he's a trained model. He is now capable enough in suggesting the correct tablet or correct uh, identification of the disease for us. So he's a trained model. So he has seen so many data before. So now, so machine learning is all about the data. So as far as we have the correct data and the representation of data in the correct format will help the machine to learn properly. So we have to tell the machine this is the input, these are the symptoms. If these are the symptoms are present, might be the patient might be suffering from this disease. So this is one of the one example. Or the house price prediction. It's one of the famous uh, problem. So where you can have say you have the number of rooms, number of bedrooms, and the square feet of the house, and where your house is located, is it nearby the market, a school, or something. So based on these constraints, we can tell the price of the house. The house might be very big. If it is interior, the price might be less. The house might be small, which is very close to market, school, and so on. So then the price might be greater. So the machine learning, we as a human, we have the intelligence, we can understand the underlying patterns. Because of these constraints, the price is high. Because of these constraints, the price is low. But the machine cannot derive on its own. We have, in order to understand those underlying patterns, the different formats, the data has to be provided in different angles so that the machine can understand, okay, because of these symptoms the price is high, because of these symptoms the price is low. Okay.
One
So
question
okay,
is there.
so next we'll understand.
Hello.
Yeah.
Yeah, one question is there. Means you said means in machine learning, program gets ability to learn itself. So what that means? Means internally, if something new is coming, then internally it writes program by itself, or it is understanding based on data changes. How exactly it is?
Yeah. So first of all, machine learning can try to classify the data based on previous learning. Say for example, say for example, you have trained some 2,500 instances of data, and the machine is now trained, and you're giving some new data as a testing phase. If it tries to fit the testing data into one of the training data, because machine learning is not the thing which cannot tell something which has it has not learned anything. Okay, so it tries to fit into one of the data which has seen already. So it tries to match with all the 205 2,500 rows of data which has already learned. Say for example, then your okay, your model is predicted. Say in your case the house price prediction. The price is very less, but you might be expected, but you might be figured it out something like 50 lakhs, but your machine learning algorithm is telling something around some 42 lakhs. So there is too much deviation, say something around some 8 lakhs. Then it is not a good prediction actually. So in such cases, what we have to do, we have to basically there are different metrics to assess your algorithms. Say for example, if it's a prediction algorithm, we have mean squared error, mean absolute error, so r squared error, so something like that. So based on the metric, if you see that your algorithm is not behaving as per your standard or as per your wish, so what you have to do, we have to take those data as to the training phase, and you have to retrain your model and deploy it again, or you have to fine tune the hyperparameters.
Hmm. Okay, I got that point, but where machine is learning by itself, means my program is learning by itself. That point is not clear.
Sorry, can you come again?
Means here
Mm,
you talked about prediction. Means
yes,
based on prediction, it is predicting. But one concept
yes.
again, you said that machine learning is learning by itself. So where that is coming into picture?
Yeah, learning by itself means, say you have some 2,500 rows, okay? Say some cancer detection. You have given the different symptoms of means whether what is the cancer, that means the tumor size, like how long they have, so on so information. So in order to say whether the person is suffering from cancer or something, you have given some 10 symptoms of data to the machine. You are not specifying that this column is very important, or because of this column only you're telling the cancer. So you're giving the data to the machine. The machine is doing the analysis, the underlying, it is trying to understand the underlying patterns. Okay, then finally what it is doing, if these are the inputs are present, okay, this is the output. So by this way, it is trying to learn by itself by understanding the underlying patterns. For example, let me just give an example with traditional programming and machine learning program. For example, in traditional program, for example, if you wanted to find a factorial of a given number, you write a small logic for it, right? So basically, you write a logic in any programming languages. You feed your input as a number, for example, 5, it gives 120. So you give data and you write a program, the output you get it. But in machine learning, what you're doing, you're going to build a model by saying the input as well as the output. So you're going to give the data as well as the output. The data consists of here the input as well as the output, and you're going to build through the through you may be opting different machine learning algorithms depending upon the use case. So if it's a classification, you might be going for logistic regression or support vector mission. If it is a prediction algorithm, you'll be going for a linear regression algorithm. Then you build a model according to the input and output, and then you deploy the model. Once you get a testing data, the testing data will be sent to this model. The model can be predicting the corresponding output.
So how we decide which model we need to give to the machine?
Sorry.
How we decide that, right? You're saying that prediction model and different models name you're giving, right? So how we decide
Yeah.
that, like on the basis of data?
Yeah, for example, if your target variable, for example, you are going to predict the house price. The price might be in a number, it's a numerical format, right? So it might be in lakhs or dollars or whatever maybe it is. So in such cases, we have to take the regression problem, which we know already. And for example, if it is a classification problem, we have to say whether the person is suffering from diabetes or not, or the given set of attributes corresponds to which color. So might be you have five different colors. Okay, you're going to classify, put them in or plant disease. If you take a plant disease, there might be a say you have five different diseases for the plant. Okay, so in such cases, the target variable you are going to find is a categorical. You are going to say either this or that. So that comes under the classification. You are going to basically classify which disease it is. In prediction, you are going to come up with one final number. What is the price of the house? So basically, machine learning will be broadly classified into classification and prediction. So depending upon the classification and prediction, we have a set of algorithms for prediction and classification. We can use those algorithms and we can predict it.
So it is a predefined, right?
Yeah,
Algorithms
there
are
are
predefined
predefined
for and
algorithms are available.
classified into two, right? Right, I'm right.
Yeah, there are predefined algorithms are there.
Okay, thank you.
Can I proceed? Do you have any more doubts?
No, I'm done. Thank you.
Yeah, thanks. Okay. So I'll move to the next slide. This one I'll come to the architecture part later. So here comes the types of machine learning. The first one is a supervised. The second one is unsupervised. The third one is reinforcement learning. In supervised learning, as the name itself indicates, we are there is a teacher for the student to guide it. So basically, teacher is guiding us. We are learning from the teacher. So supervise. So basically, I am going to teach my mission. This is the input, and this is the corresponding output. Let us take this same diabetes prediction. These are all the symptoms are present, and the corresponding the target variable is diabetes present or diabetes absent. Means the person is suffering from diabetes or not suffering from diabetes. So we are going to teach the machine that this is the input as well as this is the output. That is called supervised machine learning. Next comes the unsupervised machine learning. In unsupervised machine learning, it's unsupervised. So it's going to learn by itself. There is no one to guide. So what we are going to do, we are going to give a bunch amount of data, and we are not going to tell what is the output. We are going to just give some 10 different symptoms of a disease, and I'm asking the machine to analyze the data and find the underlying patterns and group them into different groups of data. Means I'm asking the algorithm to I'm asking the machine learning algorithm to group them into clusters, groups. Okay, these are all the symptoms are present, so this will be grouped into one group, and these are all the symptoms are present. Okay, if it is a cancer, if you take, these are all the high risk. Okay, the person is in a very high risk or in a starting stage of the cancer. So based on the symptoms, this unsupervised machine learning algorithm will group them into different clusters. Say if you have some 2500 rows of data, might be you are interested in categorizing into three groups: low, high, and medium level of cancer. So if you specify your the value, the k value, means in k means algorithm, you have to specify the k value. So how many groups your data has to be grouped. So what it will do, the unsupervised machine learning algorithm will be using some cosine similarity and equidistances. So some there are predefined formulas. So it tries to calculate between the other rows, and it will group them based on the number we specify to the algorithm. That is unsupervised. Next is a reinforcement learning. Reinforcement learning is basically it's like a robot. One example is the robot. It learns from the environment. For example, when it does the job correctly, we have to reward it. Based on the reward, it will further fine tune. One good example is, for example, we all be using this chat gpt now. So say for example, write a python program for finding the Fibonacci series or something. So it is giving a program in two formats. Okay, so this is answer one and this is answer two, and there will be a small icons below your answers. Say some copy one will be there, and thumbs up symbol will be there, thumbs up down symbol will be there. So it is basically what you do. Sometimes you guys might click copy for copying the program, and if you and after giving two responses, it will also ask you which response would you feel better or something. So you might be by analyzing both the answer, you might be clicking this answer is adaptive. So you'll be clicking on this thumbs up symbol. Or sometimes you may get only one answer, and you might feel the answer is very up for your question. So you might give the thumbs up symbol. Sometimes you may feel that the answer is not up for your question. Maybe you're in some old chat, what it tries to remember what you previously asked. It tries to map this question also to that, to the context. Basically, it keeps the context whatever you have already interacted with ChatGPT, and the current question also it tries to map until unless it is not too much variation. So in such cases, you might be not be interested with the before context. So in such cases, you might give the thumbs up symbol, and you may start and use it. So by that, what it is doing, it is trying to understand the human behavior or human mindset. Okay, so people are feeling better with this response. So for the next time, what it will do for those questions, you try to get answer. Means give some random answer or two or three answers. So that is one of the good example of reinforcement learning. Okay, so now we'll understand what is under supervised learning. What are the different categories? So one is the regression problem, and the other is the classification problem. So as I already told, regression problem means the final output into print will be a some number. It can be in float or integer, anything. So it will be some number. So like say you're going to predict the house price or the gold price or the stock market price. What will be the stock market price? It's when you use when you're using a time series data, or if you're taking a real-time example of weather forecasting. What might be the temperature in another 2 hours? What will be the temperature tomorrow? What is the temperature during the night time? So it all is a number, right? So we have to predict it basically by future data. For example, house price data, what we can have some static data like already collected data. We can have it and we can build a model. It's fine. But as time series data, say for example, if you wanted to say what is the weather forecasting, or what is the temperature right now at the stock market. You cannot like store data from 2001 till now 2024, and you can just tell what is stock price or what is the temperature now, right? So it is a time data. We have to keep analysis every minute. For example, in order to say what is the weather prediction, weather forecasting, you have to note down every second of data, or you can have some nth minute or nth second. Say after every 60 seconds you'll be noting down what is the temperature, what is the temperature. So when you wanted to say now the time is say in India time now is 7:33 a.m. So you wanted to tell what is the what will be the temperature at 2 p.m. on 26th December. So what you will do, you try to keep track of the data what is being seen now. So maybe 2 p.m. means you have to take care of from 159 158, so till maybe some 12:30. So you have to store the data which is currently current, not the data from 2001. That data cannot support you. Okay. Okay, that super. Okay, next, and in supervised we have the classification. So classification, as the name indicates, you are going to classify them. You are going to group them. Yeah, you are going to say, we have, see for example here this is one of the classification data. You have the sepal length, width, petal length, and petal width, and you are going to group them into the groups. Say they have already told this is iris setosa. So if the leaf is this 5.1 or 3.5, sorry, this flowers thing, then this present, then this belongs to iris setosa. If these are the symptoms are present, this belongs to iris versicolor, or if these are all present, if this belongs to iris virginica. So they have already gave us the some amount of data with
Sir,
classification. Yeah,
sir,
yeah, please. Yes.
sir, this we can do in Excel also, na? I mean, uh, we can classify
Yeah.
the data in Excel, giving like what we want.
But
What do we call it?
but
Um,
depends
Like
on the volume of the data, right? The volume of data is more, that is a manual intervention, right? In Excel.
okay,
If the volume of data is more, I want to capture whatever the sir is giving example, right? For capture for all the countries, right? So Excel
okay,
will not support, right?
okay. Thank you.
yeah, and also the fine tuning and others, ML empowers most compared to Excel and other things.
Hi, one question here from my side, Tushar here. So
Yeah, yeah,
let's say
please.
if I have a number of images, so I want to process images basically now. where
Yeah.
I will be providing interior room images. Okay, let's say wall one, wall two, and so on. So let's say I
Mm.
have a data sets of
Okay.
around 1,000 plus images. I want to tell machine learning to identify the objects inside that rooms so that I can render the color. Uh, so let's say I want to paint a wall, okay, but that paint should only
Mm.
go for the only on the wall, not on the objects in front of the wall. So let's say there is a clock, there is a TV. So basically,
Mm.
it should render the color only on the wall side, wall surface, not on the TV. So that is the project, let's
Yeah.
say. So in this type of scenario, which machine learning model I should go with, whether it is supervised or unsupervised or reinforced.
Yeah.
So
Yeah.
here it's most of the
So
time it will be image processing.
mm, yeah. So to answer your question, the problem statement which you have specified belongs to deep learning actually. So machine learning is not so capable in handling the images. So deep learning with the help of neural network architecture, we can proceed with the task. Basically, first of all, we you are telling that in a room you have to paint only the wall, not the object which are attached to the wall or something, right? So in such cases, first of all, it's an image detection problem. So under the image detection, we have to first do the object detection. You have to have a huge amount of data by specifying the objects. For example, means the wall clock, whatever you told. Okay, so we have to basically do the object detection. Then we have to give the ground truth so that the machine can learn. Okay, this is the under this wall. These are all the objects. These objects has to be neglected. So for this task, you have to feed a huge amount of data. Then only the machine can learn. So as a human, we by seeing the wall, okay, here's a clock. Okay, we should not do painting. We have that understanding, but the machine cannot understand. Okay, so what we have to do in such cases, we have to specify a huge amount of data, not only the walls, and what are the different objects can be in the wall also. We have to fine tune it. Then the machine learning can understand. Sorry, the deep learning will try to find the object and discard the object, and whatever you wanted, it can be achieved.
Yes.
See, in such the scenario which you have specified, the machine, see, this is all some see, high risk data sets are basic numbers. The machine can basically understand very fastly. So I think here some 1 2 3 4 5, some 15 to 20 instances of different instances are there. So the machine is learning very easily. But in your case, say you said some 1,000 images. Each image might be, just assume that 128 cross 128 images. So 128 means across 128 means each will something, I'm not sure, some 1 minute, what will be the answer of 128? So 16,384 pixels means each that one image consists of 16,384 values. Assume that only if it is a black and white image. If it is a grayscale image, it will be something around 49,152 values. Assume that for a single image you have to tell your machine 49,152 images. Assume that you have some 1,000 images. Consider how much it will be. It will be going lakhs and lakhs only for 1,000 images. For such the problem which you have specified, it is very difficult for an ML engineer or AI engineer to develop the model from the scratch. So for those concepts, we have the unique features in deep learning or the AI, that is called the transfer learning. So I'll be discussing in the upcoming workshops. So that is a transfer learning. So where a predefined model is already available in the market, you'll be taking that model and fine tune according to your requirements. Because teaching a kid, see, you wanted the kid to write 12th exam directly without studying one first class, second class, third class, it will be very difficult, obviously. So what I have to, the kid can only progress 12th class if it has progressed first, second, third, fourth, fifth, like that. So today
Example
itself
will be
the kid
like
has,
example will be like
Yeah,
OpenCV is one of the model which we can use, right?
yeah,
Which
yeah.
is already pre-built model, and on top of that, maybe we can add a few more fine-tuning parameters, right?
Exactly, exactly. So there is a concept called transfer learning that the ImageNet data set is available in online that consists of some, I think, some millions of data. It has already learned it, and about each data, I think it has learned about some 20,000 images, and about each image, for example, if it is a dog, about dog itself, it has learned 20, sorry, some 5,000, 10,000. I think I'm not sure about it. It has learned. So what you can do, you can basically take that model and you can fine tune with the data you have it so that the model can be more generalized and it will satisfy your requirements.
Thanks for that. Okay.
I'll proceed. Okay, so the classification, so here it is three class labels. So what it will do, the machine will try to understand by seeing this sepal length, width, petal length, and width, and it tries to learn that okay, if these are all the measurements, then it will remember that it is a iris setos or something. The machine. So this comes under the classification. So basically, you are feeding the X. These are all the X. These four are X. I'm feeding all my inputs and also I'm telling what is my output, that is a class label. So this comes under the supervised machine learning algorithm. Whereas my teacher is telling this is the iris setos, so iris vertical, iris virginica. Then next comes the unsupervised machine learning approach, where you give only the inputs, means only the X. The machine is going to group them based on the underlying patterns or underlying similarities between the data you provided. And you also have to specify what might be the k value, how many clusters you want it. You have provided some 10,000 data and you are interested to group these data into 5 groups. So the data will be split into five groups. The 10,000 data will be split into 5 groups. Okay. Okay. So we'll understand now the architecture of machine learning now. So the So first is the first starting phase is maybe everybody will be working on different domains. So the first is the data, right? So first of all the business understanding. So, okay, we are working some XYZ organization, and you wanted to involve a machine learning approach over there. So in such cases, what you are going to do, we are first of all our motive is to understand the business. So in this business, we have this data. How we apply this machine learning? So whether for example, one good example is in a telecom domain, the call process, right? So basically the call process should be feasible. There should be no network glitch where one person is talking to another person. There might be glitches when the person is traveling in train or some they are not in the network area or something, right? So they have to basically identify those things. The other thing is, for example, the Amazon website. If you take an Amazon website during the sale, the number of orders will be more. People try to buy more items when there is a sale, right? So the application should be stable enough to feed or cater to all the customers. The customer should not feel that the website is slow or they are not it is not interactive. So such feelings the customer should not be feeling. So in such cases, what the if you take in the Kubernetes terms and Docker side, the pods should be increased. It should be dynamically increased based on the number of customers. Though, for example, the people more will be purchasing in the daytime, so it has to see the timing and it has to keep constraint all these things, and it has to increase the pod size in order to feed the customers by having a smooth process of ordering the items in Amazon. If you take a call process in the daytime, there will be too much calls, people will be making call, but the night time maybe some after 11 maybe till morning 5 a.m. or 6 a.m. there will be less calls. So what we can do, we can reduce the pods, because the increasing the pods is also cost efficiency, so we have to keep the cost also in memory in. Okay, so first we have to understand we have collected some amount of data, and with this data what are we going to do? Are we going to tell the alarm is detected, or there is some anomaly is there in your anomaly, or that you are going to tell how much the pots has to be increased? So these are just an examples for your business. So we have to understand what are we going to do with this data. Are we going to do a classification, or are we going to do a prediction? So once you have the clear cut understanding of your business, depending upon the data you have it, then you do the data acquisition understanding. So what you do, you try to store all the data into, maybe it might be writing in the persistent volume in the Kubernetes terms. So from there you have to copy the data. It might be a time series data. Every time it keeps on writing some logs. So in every application there will be a part of logs. So logs will be keep on generated in order to study the application, whether it is programmingly, whether it is behaving correctly or not, right? So every application will be writing some logs. So we have to collect all data into one place, that is data source. Then what we have to do, we have to check whether all the data are present. For example, if there might be some missing data, maybe at the 16th interval, the data 16th second the data has not been written by the applications. So such cases we have to identify, okay, the data is not written. So whether we have to impute some data to it, or you have to remove that column, because before we feed the data to the machine learning model, the data should be cleaned and there should be no missing values. So this is the important thing we have to keep in mind. So we have to take care of all the process called, first the ETL, this business understanding and data acquisition comes under the process of ETL, extract, transform, and load. So you are going to extract the data from, say, some from persistent volume. You are going to transform the data according to your requirements, and then you are going to load the data for your model and for model building. Once you load the model, the next process is called EDA, exploratory data analysis. So what are the data you have it, whether this data is really required for building a model, whether it will help us in prediction, whether it will help us in classification. So such analysis has to be made. Here comes the statistics part. We have to understand whether the data is right skewed or left skewed, or whether the data is normally distributed, or there are too much variance is there. So such analysis, or is there any outliers which deviating the whole model? For example, one good example of outlier is for example, you have collected the XYZ organization salary. You are going to find the mean. When you have a CEO salary into the calculation, it will deviate the too much variance. Say I have my 2 years of experience in some XYZ organization, my salary is so and so. If CEO salary is included in calculating the average, my salary will be too much variation. Yeah, I'll be having too much variance. So the standard deviation would be too much. So these are all the study we undergo in exploratory data analysis. Say you have some 10 features to predict the house price. You have to check whether this what to say, this feature is really important, or it is not. If it is not important, we can basically discard that feature, because we have to keep in mind the storage and the processing and the computation, everything, when we build a model. So these all things will come under the part of EDA, that is exploratory data analysis. Once you have done with all the steps, then you go for the model building. So you build the model, you tell the machine this is the input and this is the output, and I should, as an ML engineer, I should have the intelligence to select which ML algorithm for this data. Then once I selected it, I'll be building the machine learning model. Then I'll be testing like a soft how the SDLC life cycle works the same way. Then I'll be testing my model with some more amount of data, or you can do it validation. The difference between validation and testing is, validation is, for example, you're first building a model. Say you're, first of all, you have 100% of data. You're splitting first the data into 80-20 ratio. So you're taking some 80% of the data, and 20% of data you're keeping it for testing after you build the model with 80% of data. So this 80% of data, first what I will do, I'll take 70% of the data for training. I'll keep 10% aside. I build the model and I test with this 10% of data. If I'll see what is the how my machine can behave. If there is too much deviation, I'll do the second iteration. I'll build my model with 70% of data and I'll check the validation. So likewise, validation is before testing in order to see how your machine is learning the data. Once it is completed, I'll do the testing part. Once I see there are predefined metrics for each algorithm. Say, for example, if it is a regression problem, we have different metrics to assess the model. If it is a classification problem, we have different metrics to assess the model. Once you have assessed and you are confident that the model is behaving well, you put the model into the deployment for customers, and customer starts using it. If they feel too much deviation for their use for their inputs, so a right action has to be taken. We have to collect a good amount of data from them, then we have to fine tune the model and retrain it and redeploy the model. So a constant a checking or a drift kind of thing has to be injected to in order to assess the model at every cost of time. So then the customer acceptance, and then it comes to an end. So this is the basic life cycle of machine learning.
Can you go to that flow of
Yeah,
that?
yeah,
See, here, if you see that there is a start point and the end point, I understood, right? But
yeah,
the arrows are bi-directional, right? So can you
yeah,
tell me which step one, step two, step three, which one is going in a flow, right? I'm confused with this,
yeah,
right? So see, business understanding, then modeling, and then data acquisition, then there is a bi-directional between the modeling and the data acquisition and all that. So just want to at a high level how it flows, right? We'll take one model like we are going to create that, right?
yeah, exactly. So for example, first the starting phase, so you understood the business, you do the data acquisition and understanding, and you're building the model. And if you see there are some missing values and the data is not so proper, we go back to the previous step. We further fine tune the data. Maybe it requires the data in the integer format, but you're feeding some data in a string format or something. You go back to the data and you do again the pre-processing and do whatever the steps you wanted, and you build the model. Once you build the model, you do the deployment, and once you deployed it, you test the model, right? If you're testing it, your the model is not behaving so and so, so either you have the option to change the model, whether any other model means you have different algorithms, right? So whether
Yeah.
this algorithm is may not be a good fit. Sorry.
Yes, you're right. Please.
Yeah. So maybe you can opt a different type of algorithm for the same scenario. Maybe that algorithm may work better than this opted model right now. So basically, you can take that model and you can try to deploy it with that model or something.
Okay. So the testing and validation will come here in the after the deployment, right? In the deployment box, right?
Yeah, testing and testing will come here only.
Where the
Once you
ETL
are sure
come.
about your testing, then you deploy your model.
Okay. Where the ETL come actually?
ETL comes here, data acquisition and understanding.
Okay. Fine. Thank you.
Thank you. So here it is. Get data, you clean, prepare, manipulate data, train model, test data, and improve it. So as I already discussed, this classification, regression. Okay. So right now I'll be telling the few basic terminologies which we'll be using in machine learning. So assume that this is my data set. Right now I'm going to tell what is the age of that person. I'm going to predict the age of the person. That age is basically called as target variable or dependent variable or outcome variable. Any three terms, sorry, any one of these terms will be apt for this age column. Target, outcome, or dependent variable. I'm just ignoring customer ID because it makes no sense for me. Customer, gender, education, occupation, and affinity code are my four. These four columns are called as my independent features. Okay. Why this age is called dependent feature? If I wanted to know my age, I am depending on all these four columns: customer, gender, education, occupation, and affinity code. That's why it is the target variable is otherwise called as dependent variable, because it is depending on the other features to know its own result. The others, there is no relationship between these two columns. If they're having too much relationship, means there are metrics in status like correlation or principal component analysis, SNE. Some there are different things are there. Or covariance, which you might have already known. So if there are, say for example, in order to, I have to know some output. If both contributing to the same thing, then no use in having the another one, right? For example, customer, gender, and education are the two different columns. Assume that they are somehow different. So for example, let us take this affinity card. Okay, zeros and ones are there. What I'm doing, I'm just multiplying. I'm having affinity code 2 number, affinity code 1. This is affinity code 1, affinity code 2. What I'm doing, I'm basically taking the whatever the values is there, I'm just multiplying into 5. So what it will be, 0 0 0 5 5 5 0 0 0 0 0 5, it will be there. But basically the affinity chord 2 is a multiple of 5 multiple of affinity chord 1, right? So there is no use in having such column in my data set, because it's basically whatever the affinity chord 1 tells. Basically the affinity chord also tells, but in terms of multiple, but makes no sense, right? So such analysis also, say for example, if you are collecting some 10,000 features for predicting the age, you have to analyze whether this feature is really important in consideration, or it makes no sense, means you have to drop it. So these are all basically comes under the EDA part. Okay. For example, in predicting, depending upon the requirements, you have to analyze the columns which you are considering for a model building.
So will you take EDA also?
Yeah,
Tell us a bit about EDA.
yeah, sure. Okay, 1 minute. I'll just quickly show about the EDA step. Okay, will play this. So this is the unsupervised learning. You give only the data to the algorithm, and the data it understands the patterns, the data itself, and it just tells it belongs to which group or something. Okay. So basically, you guys can see, given email labeled as spam or not spam, learn a spam filter. So you're already labeled it whether it is a spam or not spam. So it comes under supervised learning, and it's a classification problem because you have a binary outcome, spam or not spam. Given a set of new articles found on the web, group them into set of articles about the same story. You are going to group them based on the same story. I've not told the machine this belongs to murder story or something. I have not trained the model. I've just given the stories only to the machine. The machine is going to group them. So it comes in an unsupervised machine learning, and is it is going to do clustering. Classification is different, clustering is different. Classification comes when it is a supervised. You already taught the machine this is a patient with diabetes or not. Clustering is it's going to group them. The third one, given a database of customer data, automatically discover market segments and group customers into different market segments. So here also I have not told I have not labeled it, so it's going to do unsupervised clustering. Fourth one is patients diagnosed as either having diabetes or not. So it is going to say whether it's I've already labeled as diabetes or not. So it is a supervised approach, and it comes under classification. Got it, guys?
Uh, yeah, Janarthas, and I just want to know, I will be like writing a program in Python for
Mm.
spam filter.
Mm. Yes. Yeah, please. Yeah, I could not hear you.
I will be writing a program for this email spam filter. So,
Mm.
is that program a part of this machine learning?
Yeah, obviously. For example, you have to how in a general programming way in Python program, how will you write the program by how will you teach the program if these content are present, it will be spam. If these content are present, how many if else statements will be keep on writing?
Yes, true.
That's why we go for
Okay,
the machine learning approach.
okay. Now I got
Basic
it. Thank
programming languages, you use the if else conditions in order to teach the machine. If this is a condition present, print this. If else if, how many else if, how many words you are not sure about the words. The email content you will have a huge amount of data, right? You have to tell all conditions by writing all conditions. That's all. You cannot do it.
True. Now I understood like what it is about.
Yeah.
Thank you.
Yeah. You asked about the EDA part, right?
So today we can go with the flow. You can take the EDA in some other session, I guess, if that
Yeah.
works for
Yeah.
Actually,
you.
I had a plan to. Yeah.
Now, can we connect tomorrow for the detail, right? It will be.
Yeah. Sure. Then. Fine, guys. I'll stop it here then for today.
Okay. Thank you.
Thank you, guys.
Thank you, sir.
Thanks,
I had a
everyone.
plan to start statistics, but we didn't get time to cover statistics. Maybe we'll try tomorrow then.
Thank you.
Jana, can you share the recordings, please?
Yes, I will share. I will share. Yeah, I'll share in
Yeah,
the
yeah.
group.
Arvind sir
Arvind
will.
sir, stay online for some time
Hmm?
in this call itself. Once everyone will get disconnected.
Yeah, okay.
Arvind
Mm-hmm.
sir, I
Uh,
also wanted to have a chat with you. Shall I send
mm.
a message
Okay,
on
okay, yeah.
WhatsApp?
I'll, yes, okay.